we'll get started. So good morning, everyone. This is Peter Smallage. I'm the New York State Extension Forester at Cornell University, and it's a pleasure to welcome you all to our April 2021 webinar. We are joined today by Dr. Nan Pond, who works with SilviaTerra, and she's going to be talking about remote sensing and a nationwide forest inventory. And there was the backstory on this is I saw an email or a notice somewhere about a new program that SilviaTerra has rolled out as a carbon market for landowners. And I remember there was a lot of activity about carbon markets, I'll say 8 or 10 years ago, and then it seemed like it went silent for a while, and then it's reemerged with this. So I got a hold of an employee of SilviaTerra that was working with the landowners in that carbon market and thought, hey, we've never had anything kind of on the remote sensing satellite side of forestry. And so Alex connected me with Nan, and she agreed to offer this webinar. So Nan's going to introduce herself, and I'm just going to mute my microphone and welcome you all here. And Nan, it's all yours. I really appreciate you joining us and look forward to seeing your presentation. So thank you.
Sure. Thank you, Peter. Hi, everybody. I'm Nan Pond. I am originally from upstate New York. I grew up in the Hudson Valley and did an undergraduate degree in forest ecosystem science from SUNY ESF. After my time there, I spent a few years in Zambia with the Peace Corps, and then went to Michigan Tech in the Upper Peninsula of Michigan for grad school. And while I was in grad school, I went in thinking I wanted to do like quantitative silviculture and study how to do more targeted outreach to small forest landowners. And my advisor said, take as much statistics as you can handle first. And I came out a biometrician instead, which, I am thrilled to be doing the work that I'm doing now, where we get to combine statistics and remote sensing data in ways that are actually very relevant and are designed to make more data available and more opportunities available to foresters and small landowners. So, as Peter said, remote sensing is new for this webinar series. And so I decided to sort of start at the beginning and go through some of what remote sensing is, and then some of how we've used it internally. So this is what I'm hoping to cover today. At the high level, like why use remote sensing data and what are different types of sensors and data that might be covered under this description. I'll spend some time going through some of the off-the-shelf products that exist, and then sort of wrap up by talking more specifically about the data product that my team developed. So that's covered under why would a company make a nationwide forest inventory and what are we doing with it? So one of the things to think through is like, what is remote sensing? And remote sensing at its core is any information or data that are gathered without having to make a direct observation. So cruising is one of the most direct observations that foresters can do, right? You're in the woods, you're wrapping a tape around a tree, and you're writing down exactly what you're seeing. Whereas remote sensing data is getting similar types of information, but without having to directly engage. So remote sensing can cover a huge range of different types of data, ranging from UAVs or drones, small aircraft, satellites, Lidar data sets. And then one of the most straightforward ways that most of us engage with what's really remote sensing data on a daily basis is something called Google Earth, right? Google Earth or Google Maps. Anytime you pull up an aerial image, you're using remote sensing data. Maybe not in a rigorously quantitative way, but you're taking that information and doing something more with it. Another way to think through when and why you might use remote sensing data is this concept of managing or understanding beyond the mean. And the way that I think through this is that if you look at this graphic of a stand, if you were putting in a grid of plots and doing a cruise of this property, as you were walking through, you would be both making measurements at each point and getting a general sense of how the property felt as you were walking through it and what you were seeing. We can get that same type of range of information of the variation that's within this property by looking at this aerial image. You can see that there's some more densely stocked areas. You can see that there's bare ground or what might be a failed plantation. We can see right in the middle, there's what looks like maybe a hardwood draw, and surrounding that, there's what looks like it might be row-thinned pine. So if you put in a cruise of this stand, you're going to get the same kind of information. You're going to know, I walked through that. There was some bare ground. You might in a hardwood forest be thinking like, okay, I can look at this data and I know all the hemlock I measured was in that one corner where it was a lot wetter and it was lower there. But when you get back to the office, when you work up the results of your cruise, oftentimes what we retain is just the average that we measured. Right. So you have, okay, here's the average basal area. Here's the average volume I saw out there. But it's hard to retain all of the detail that you captured and understood as you were walking through it. And without maybe going back to an aerial image. So this pink graphic in the middle is sort of, this is what you have left, right? You have the average condition. That's what you have when you look at your cruise summary data. And what's shown on the rightmost panel is a model of rasterized basal area across this area. So you can see that the highs and lows, so black is the lowest value and it's going up to that pink as the highest value. The dark patches are following where the bare ground is. And that visual, along with the aerial data, gives you a lot more information about the variability of the stand than just having that average number. So this is one of the ways that remote sensing data can be really powerful, not just in describing, but also as being a very fast reference back to, well, what do I know about this property? So I'm going to spend a little bit of time now talking through some of the different types of remote sensing sensors and different types of data that are available. And I found this graphic in a recent paper, Lechner et al. This paper is publicly available if you want to look it up later. It's a bit of a more technical description of remote sensing data sets and a little bit more discussion focused than what I'm going to be going through today. But there's some really good graphics, and I would encourage anybody that wants to dig into this a little more. This was a really good reference to look through. So what are the different categories and types of remote sensing sensors? Well, ground-based sensors are, a good place to start. This might be, and in this case, we're calling that anything that's up to about 150 meters off of the ground surface. So a drone is still considered ground-based, mostly because they can't fly super far without having to come back to the operator. A lot of Lidar sensors are also ground-based. So those might be a sensor that you mount on something that's like a surveyor's total station and take it out and make measurements similar to how you would go to a plot center and cruise the data, measure the trees right around plot center. The Lidar station does something similar. Airborne remote sensing, includes things like aerial photography. So I think a lot of us are familiar with that. I know, I did, a semester of like ortho photo interpretation when I was getting my forestry degree. So all of that is remote sensing data. And a lot of different kinds of sensors are airborne. So there's multispectral and hyperspectral sensors that can be mounted on aircraft, as well as Lidar. So Lidar from the ground, but air-based Lidar is also a very, very common way to collect that type of data. And then there's spaceborne sensors. So this includes a range of satellites, multispectral, hyperspectral satellite sensors, synthetic aperture radar that's on the satellite. There are some spaceborne Lidar systems as well. And then the space shuttle is here. Obviously, we no longer have a shuttle program, but a lot of radar data was collected by the shuttles over the years. And a lot of the digital elevation models that are used today are based off of some of the radar data that was collected by shuttle orbits. So if you've used any kind of digital elevation model data sets, you've probably engaged with data that was collected by the space shuttles. Another way to break down different types of remote sensing data is by considering active and passive sensors. active sensors emit their own source of light or energy. So they send out a pulse and then they measure the return that comes back, knowing exactly when that pulse was sent. So this is how radar and Lidar work. Passive sensors are simply measuring reflectance, and that usually means measuring sunlight. So aerial photography, photography is just simply capturing the way that the light is coming in. And Landsat and Sentinel and other hyperspectral satellites are similarly, they're passive sensors. So they're not emitting anything. They're simply measuring what's being reflected. It's important to remember that active sensors doesn't mean that like an individual is taking an action. So aerial photography seems like it could be active because you have to fly the plane, or if you have a drone, you are acting to get that data, but it's not how the operator is behaving. It's how the sensor itself is, whether the sensor itself is sending out an illumination pulse and measuring what comes back or not. All right, so one of the things that always comes up when you think about remote sensing data is drones. Drones have been really increasingly common, I think, in forestry contexts over the last decade or so. And I know a wide range of managers who use them. And then I've also had a lot of conversations with people who, they want to use them, or they bought a drone and they're trying to figure out what they're supposed to do with it now that they have it. And there's a huge, basically the way that a UAV is working in this kind of context is that you're flying over an area and collecting video footage. And then you go back to the office and take a look at what you saw. So there are some software programs that sort of help you quantify what's collected from a drone, but more often than not, it's more observational measurement. So it might be something like, hey, there was a big ice storm that went through. We want to get a sense of what kind of damage there was. You can fly drone, collect the footage, take a look at it, and understand sort of the magnitude of what's being seen out there, which parts of the stand or the forest might be more heavily damaged, that kind of thing. Drone footage is also really useful for measuring plantation establishment. So being able to sort of scan a large area at a relatively high resolution and understand, where are seedlings well established and where are they failing to grow. Another platform that you have probably heard a lot about are microsatellites. Microsatellites are small satellites. They're often launched as what's thought of as a larger constellation. So many small satellites, they're easier to build, they're cheaper to build, and generally when they're launched, you launch a whole bunch of them at once and then sort of take all of the data in concert that comes off of them. So if you're familiar or have heard of Planet Labs, they have a few microsatellite constellations that they have launched and operate and get the data from. And microsatellites typically are collecting fairly high resolution information, so 3 to 5 meter resolution, sometimes even finer scales than that. And often it's what we call 4-band. So the 4 bands are red, green, and blue, which makes the kind of image that we're used to looking at, and then also a near infrared return. There's also hyperspectral sensors, which are also typically spaceborne satellites. And these are generally larger satellites that operate for a longer time frame. And a lot of these are from like government research programs. So common hyperspectral spaceborne sensors are things like Landsat and Sentinel. Landsat is a US government, sort of science and monitoring satellite. Landsat 8 is the current version of this satellite that's orbiting and collecting information. Landsat 7 is also still orbiting and collecting information, but it's a little bit broken. So the data that's coming off of it takes a lot more post-processing to be useful. So Landsat 8 is really the one that's most commonly used. And I believe that Landsat 9 is scheduled to launch sometime next year. Sentinel, there's Sentinel 1 and Sentinel 2. Sentinel 1 is radar, and Sentinel 2 is collecting hyperspectral data that's similar to Landsat, but launched and maintained by the European Space Agency. And those are sort of two of the most more common examples. Both of those are producing data that's publicly available. But there are other satellites from other countries or maintained by other countries as well that are collecting similar data. Hyperspectral data set mean that it's not just collecting the sort of visible light spectrum that we're all used to looking at, so like red, green, blue, but a much larger range of light wavelengths and returns to sort of get a wider range of information about what's being reflected around the ground, and data that are useful for both like vegetation monitoring, but also oceanography and research about like weather systems and that kind of thing. Another very popular remote sensing sensor is LIDAR. So LIDAR, as we talked about before, is an active sensor. It's emitting a lot of pulses and then collecting the returns. And what you do is build what's called the LIDAR point cloud. So if you look at this image, if you look really closely, what we're seeing is lots and lots of individual points. But it's easy for us to look at that and say, okay, but I see that those are trees. I can see the trunks, I can see the branches. And you, as you stare at this, you sort of fill in for yourself, and I can see where the leaves would be if they had leaves. And what we can visibly see has also been the focus of a great deal of research to write software algorithms to be able to take our assessment of, yep, those are all different tree stems, and train a computer program to be able to also identify, this is how many stems are out there, this is their relative position to one another. And then to go further and also sort of take this type of information and estimate the diameters of those trees. This is an example of a ground-based point cloud. Collecting information is also collected from aerial sensors. And in that case, right, you can sort of manipulate the point cloud to be able to see it as though you were in a different plane. So LIDAR is really useful for getting tree heights and can be useful for getting diameters. It has been more commonly used in conifer forests, although it's increasingly used in hardwood forests as well. And the difference there is simply that, if we think about how a conifer grows, there's a lot less branching. It's a lot easier to know where the top of the tree is. Any of us who've spent time cruising in the Northeast understand that sort of intuitively. We've all struggled with trying to figure out exactly where the top of that oak or maple is. Whereas in a conifer stand, it's a lot easier to find the very top of the tree. And that same sort of analysis is a lot easier to train a computer program to do as well. But as the techniques have gotten more advanced and researchers have gotten a more nuanced understanding of how the data sets influence the conclusions that can be drawn from them, it's easier to apply these same techniques and get this kind of useful information from hardwood forests as well. Finally, radar. Radar is another active sensor. Like LIDAR, it is less impacted by clouds, which is really nice because if you have a spectral sensor that's flying over and taking pictures and it's cloudy that day, you get some really good pictures of clouds, whereas the pulses emitted from radar are not as influenced by that. So radar has a lot of uses for terrain models and like hydrology and geology, in addition to forests, because it sort of penetrates. Some radar and also LIDAR sensors will penetrate all the way down to the ground surface and help you understand just what the tops of the trees look like, but what they're growing on and how that terrain looks underneath. So that was a lot of different choices. And if you're thinking, I thought maybe I would learn how to use remote sensing for the work that I'm doing, but now I just know there's a whole bunch of options and I'm not sure how to think through them, you wouldn't be the only one asking that kind of question. And the way that I would encourage you to think through this is that remote sensing, a great deal of different sensors and different types of data, it's useful for different purposes. And none of these options is a silver bullet. There's no situation where you're like 100% of the time LiDAR data would be exactly what I need. And so rather, the way to think through this is like, what is your inventory context? what type of data do you want? And what decisions will these data help you make? Collecting remote sensing data is the first step to figuring out how to use it to make a different decision for yourself. I have known a lot of different organizations over the years who have collected LiDAR data and then sat down and said, okay, we spent a lot of money, we have this information, what are we going to do with it? So it, especially for smaller scale managers, it's very important to think through, what do I need to be able to do? And then what data is going to help me do that more effectively? Rather than getting the data and then trying to sit down and figure out, how can I make this work for me now that I've invested in it? A few different ways to compare and consider these different data sets are how useful the type of remote sensing platform is in getting you species information, forest structural information, the spatial resolution of the data that's being returned, and then the cost to acquire and process the data. And you can see there's a pretty wide range here. Something like Landsat, you can get a lot of species information, but it's harder to get structural information because you're getting, essentially a picture of the top of the forest and you don't know quite what's growing underneath. It's a 30-meter resolution, so not as fine scale as a lot of other information, but Landsat is free. And I'll go through later how anybody can access that data. And it's relatively uncomplicated to process and very low cost to do that as well. Compare that with some of the data that's available from Planet, where you have the same type of spectral information to get species. You can get a little bit more structural information because it's a much higher spatial resolution. So like a 3 to 5 meter resolution is the kind of resolution where a person can look at that and draw some conclusions. And broadly speaking, if you can look at an image and draw conclusions, you can probably teach a computer program to do the same thing. But Planet data is much more expensive. They're a private company that this is their business model, so you have to purchase the data and possibly pay additional for some post-processing. So this isn't supposed to be a fully complete table to help you assess things, but rather just these are some of the axes to think about if you're exploring remote sensing options for a particular project that you're working on. What you want to be able to get from the data, and then how important it is to have specific time, observations from a particular point in time or a spatial resolution. Another time that the temporal resolution is really important is if you're trying to collect data for some sort of post-disturbance assessment. So again, like if there was a large ice storm or a blowdown event, it may not help you if you're saying, well, I'll use Landsat data because that's really, very easy to acquire. But if there isn't any data from right after the disturbance event, then that's not helpful because you want data that represents the ground condition you're trying to assess. And that's another reason why some of these, maybe you're going to fly LiDAR, maybe you're going to, purchase Planet imagery or even pay to have them monitor a particular area at a particular time. And some of these sensors can be a lot more useful than, walking through the stand by hand or on foot and understanding like, okay, what did I observe out there, right? You want to be able to be more efficient in it. And that's where remote sensing can really help. All right, so I know that many people are not in a position where they think I'm going to learn to post-process remote sensing data by myself to solve my forestry problems. So I'm going to spend a little bit of time talking through sort of the off-the-shelf products that exist and how someone can engage with those sort of right off the bat. So we did talk already about something like Google Earth, Google Maps, or Bing Basemaps, the kinds of maps that if you're in a GIS system, you can sort of pull up and have behind other spatial files that you're working with. That is remote sensing data. And sometimes that's all you need and you don't need to go further than that. But one of the challenges to using something like Google Earth or Google Maps is that you don't necessarily know exactly when the data underneath are collected. And I'm sure many of us have had the experience of pulling up the Google Street View of our neighborhood and saying, hey, whose car is in my driveway? Oh, this must have been taken before I moved in. That's somebody else's vehicle. So if you need to know what the ground looks like right now or at a particular point in time, one of the other data sets that you can use to get a handle on that is something like the Landsat data that I talked about. This is a picture of what it looks like to go to the USGS's Earth Explorer website. It's fairly straightforward to use. You can make a free account, and then you can search through more than a decade of Landsat data to get exactly what you're trying to find in a particular area. So in this case, what we're looking at is a display that's just south of Indianapolis, Indiana. And you can search for a precise location within the system. You can upload a shapefile and say like, okay, I want to know, what are the different paths and rows where the satellite crosses this point on the ground. And then you can look and see what data are available. Here we're displaying 3 imagery dates: June 3rd, May 19th, and April 16th. And this Landsat passes over is just about every 2 weeks. But you can also filter for cloud cover and say like, hey, if it was 100% cloudy, I don't want to see that image because it's just going to be a picture of what the clouds look like and not what the forest underneath looks like. In this case, you can see that there is some visible cloud cover in the north part of the scene. But if you're interested in this point on the ground that's labeled with the number 1, there's no cloud cover there at that point. You can also see, just looking at the 3 images that are available here, you can see the green up taking place. So you go from the end of April to the middle of June. So depending on what other types of information you're trying to get, understanding what season you're looking at is also really important. Finally, you can tell that most of what you can get from this is like green and brown. And then you can also see some of the water features that are present on this landscape. This is not high resolution imagery. And if you zoom really far in, you see different shades of green and brown. But sometimes that's what you need. You're trying to understand conifer and hardwood distribution. Even if you're not planning on building statistical models from anything, if you're familiar with how forests grow, you can get some pretty confident conclusions just from looking at data at this scale. You can download these data products and pull them up into a GIS system. So this is that same imagery downloaded and opened in QGIS, which is similar to ArcMap, but a free software program that can be downloaded and used. So again, you can see you're getting different shades of green and some brown. I have used data in this context successfully to understand things like, was there a disturbance in this particular part of a forest? So while it feels a little bit crude, sometimes that's exactly what you need. You can pull down 2 dates of imagery, pull them both up in your GIS system and toggle on and off and say, hey, this was green and then it was brown. This got harvested between these 2 points in time. And that can be really useful information if you're trying to understand the history of a property that you're looking at, if you're trying to understand the extent of a fire. Larger scale fires show up really clearly, even in this 30-meter resolution. So if you don't take too much else away from this, take a look at the Earth Explorer website, download data for a forest that you're familiar with, and get a sense of what could I maybe conclude from this imagery that I can't get just from Google Earth because I don't know for sure when those data were captured. Another data set that can be really useful is the NAPE imagery from the USDA. This is the National Agricultural Imaging Program, and aerial imagery is flown about every year across most of the country. And these data can be downloaded from this same data gateway webpage. You can also download elevation raster data sets and other like temperature information. So there's a lot of remote sensing and raster data sets that you can pull down from this site if you're interested in getting that kind of information. All right, so what are some of the national scale data sets that might be available? If you want to know like what's out there that covers the whole country, and or maybe what's out there that covers my part of the country. My apologies to the Canadians listening in. I'm not as familiar with national scale Canadian data sets, so we're going to focus on the US for this part. But I wanted to share a little bit about a few Forest Service products that I am aware of. Again, I do not work for the Forest Service, so this is what I know of, but I can't speak to the details of a lot of these. One is that there's a product called Basemap that the FIA has been working on for the last 5 or 6 years. And I heard them present on this at the SAF convention last fall, and I believe that Basemap is expected to be released to the public at some point this year. There's a similar 30-meter resolution data product from the Forest Service Fire Lab called TreeMap that I have found some information about online. And finally, if you're familiar with the Land Fire Program, that's another national scale vegetation assessment that is available. All of these, the Basemap and TreeMap are 30-meter resolutions of inventory estimates of a particular point in time. So I think Basemap is going to be a 2018 data product. And I'm not sure about Fire Lab, but I don't believe that they're continually updating that data set. But it's, it's pretty fine scale information, and it's something that should be available to the public, to my knowledge. A few other large scale data sets that are available and are essentially post-processed remote sensing data. The Global Forest Watch is a fantastic organization. There's a huge amount of resources available on their website. Most commonly, I think Global Forest Watch comes up in conversations about monitoring tropical forest deforestation, but it's also a very useful resource in the US. And I know that SilviaTerra, we rely on some of their data products for disturbance and land use history information. Finally, I know that there's a New York forest carbon assessment that's underway. I can't speak in great detail about this, but that's one of the websites that's available. And I know that there's some efforts underway at SUNY ESF to do fine scale modeling of carbon across the state. So having shared some of the national scale products that are currently available, I'm going to switch gears a little bit and talk about the one with which I'm most familiar. And this is SilviaTerra's Basemap data set. So the starting question is, well, why would you make a nationwide forest inventory? SilviaTerra was started about 11 years ago. And for the first decade of our existence, we did a lot of remote sensing based forest inventory work for large owners. So a lot of TIMOs and REITs across the US, building out a system and a process for taking ground-based measurements. So cruise data that was either installed by a design that we created or cruise data that already existed on a property, combining that with remote sensing data, usually a stack of some of the different products that I've shared today, and using that to generate a high resolution imagery or inventory estimate for a whole property. Going back to that initial point I made about managing beyond the mean. So what we were able to do is generate for individual owners, high resolution information about not just their current stands and summarized to their current stand boundaries, but also information that was agnostic of stand boundaries, so you could redraw bounds and capture variation in a different way. We took everything that we learned from that and set out to build a national data product for a few reasons. One, because we have some really clear end goals, particularly the carbon program that Peter alluded to at the beginning. But also because we knew we had a system that worked well for doing this, and there was no reason why we couldn't run it at scale. So in 2018, we received a grant from Microsoft through their AI for Earth program, and we built our Basemap data set. Since then, we have devoted a lot of time and energy to benchmarking this data set, understanding how well it's performing in different parts of the country, and improving the ways in which we fit models to field data to develop this information. So we took everything we learned from 2018 and we made a new version of Basemap that was using 2019 imagery and just completed the 2020 data set last week. So the magic behind Basemap is just math. It's a tree list based inventory for the entire US at a 30-meter resolution. And what we're doing is taking Forest Service FIA plot data along with high resolution imagery, the exact remote sensing data that I just walked through. So we use NAPE, we use digital elevation models, we use Landsat data and Sentinel data to generate statistical models and predictions for each 30-meter pixel across the landscape to create this national scale inventory estimate. Some of the Forest Service products are made in similar manners. So they're also using FIA plot data to train models, and they're also using remote sensing data to make predictions. One of the key differences is the exact models that we use allow us to predict a larger range of forest conditions than what Basemap produces. And the other key differences as a private company, we are devoting, it's really of interest to us to not just have a single data product, but to repeatedly create this data product. So as I said, we've updated it annually, and we're looking to produce it on even more frequent time scale in the future. I wanted to talk a little bit about the FIA plot data. I know that not everybody's familiar with this program. So this is the Forest Inventory and Analysis Measurement Program. This is our national scale field forest inventory. There are plots laid out across the forested United States. There's 1 point per 5,000 acres. And plots are remeasured about every 5 years in the eastern US and every 10 years in the western US. And so this is a huge amount of information about America's forests. And on its own, you can work up large scale summaries, and there's a bunch of different Forest Service tools that you can use to get this information. Combining it with remote sensing data lets us fill in the gaps between those points. So 1 plot per 5,000 acres isn't very much information, but when you combine that with remote sensing data, you get something like our Basemap data set. Here's a few visuals showing how the Basemap data set compares to underlying ground and what kinds of information we can pull out from it. This is a visualization of trees per acre, ranging from 0 to 10 in this dark purple color, up to like 400 trees per acre in this chartreuse. So you can see that we're able to capture the variation across the landscape and understand where are the highs and lows. Okay, there's lower stocking along these draws. You can see where roads pop out, that kind of thing. We're also able to generate heat map visualizations of species composition. So for every 30-meter pixel, we have an estimate of the number of trees, the sizes of those stems, and the species composition. And that tree list is used to visualize all of these different rasters. So in this case, we're seeing hardwoods in this reddish pinkish color, incense cedar in green, and white fir in blue. I think this is an area in the Sierra Nevada mountains. So again, you can sort of see the range of species mixtures across this landscape. One of the really exciting applications of a data product like this is in forest health. We're generating large scale, small area estimates. And that means that if you're looking at a species like ash, where we're trying to understand possible impacts of emerald ash borer, we can use it to look at distribution of ash across the entire state of Wisconsin, which is useful for these like landscape level forest health assessments. But if you're a consulting forester, you don't want to know what's happening to ash in all of Wisconsin. You want to know about the properties that you're of particular concern to you. And we can zoom right into a few properties and see what's the distribution of ash within these holdings, and understand like which areas might we target to go out and take a look and see like, is there damage from emerald ash borer already? If we're thinking about prioritizing stands for harvesting treatments, if you're primarily concerned about removing ash before it's killed by the borer, you might be able to use this type of data and say, okay, well, the highest ash density is in this parcel, so that's where we're going to go out and mark first. So again, having these like landscape scale but small area estimates is what makes Basemap or any other like national scale data project an extremely powerful tool. We've also been really interested in using it to develop different estimates of wildlife habitat quality. This is a series of images produced by one of my coworkers, Brian Clough, generating estimates of moose quality moose cover across northern Minnesota. So this is on the north shore of Lake Superior. What we're seeing here is low quality moose habitat in this darker purple color, high quality in this yellow. That big purple blob in the northwestern corner is the extent of a fire that took place a few years back. So as it's regenerating, it's low quality habitat, but it kind of looks like a seagull, and that's not an artifact of the data. That's actually what the ground condition looks like underneath. So we generated this set of estimates of moose cover habitat across this area, and then compared that to stated moose harvest locations from recorded by the Minnesota DNR. And what we can see here, although it's in a relatively small inset, is simply that the highest concentration of where moose were harvested overlaps with this area that was labeled as the highest quality habitat. And then along the lakeshore, there haven't been a lot of moose taken. And that's likely because it's not a very good quality habitat for them to live in. So you can imagine if you were a hunter and you had the opportunity to engage with this kind of data, it might help you plan where you might go next or where you might be scouting, because you can get this type of habitat quality information before you head out to the woods. We've gone through similar exercises mapping habitat quality for other species. This is a visualization of white-tailed deer habitat across the US South, dated to 2020. So again, we're seeing areas of high and low, and then you can see if you were to zoom all the way in, you'd be able to get sort of parcel specific information about the quality of the habitat for white-tailed deer. Here's another image showing estimated habitat or potential habitat for red-cockaded woodpecker. This is the Florida Panhandle, and you can see on the left side of this image, there's a pretty high density of this red color, and that's actually Eglin Air Force Base, which is known to be pretty high quality habitat, just because of the way that they are managing those forests and because of the amount of controlled burns that take place there. It's created pretty good woodpecker habitat, and so that's the kind of first pass validation that we look for in these kinds of models of like, are we seeing that we're predicting high quality habitat where we know that these threatened and endangered species actually do occur. Finally, one of the primary motivators for SilviaTerra in creating this data set was to be able to generate landscape scale but high resolution estimates of forest carbon. This was done in service of our natural capital exchange, which Peter mentioned and which you could find information for on our website right now. This is a visualization of acres enrolled across the US South in this 1-year forest carbon rental program. This is for a cycle that enrollment took place in March, and the 1-year term commitment for these landowners started on April 1st. So we're able to make this program available to people with 10, 15, 40, 100 acres, as well as much larger landowners, because we have the same quality of information for every parcel across this area. If you're interested in learning more about this and about how we're using this data to facilitate this program, again, there's information on our website, and enrollment is available for the Lake States and New York and Pennsylvania right now. So in conclusion, that was a lot of information about remote sensing data. And what I would encourage you to take away from this is that remote sensing is an efficient way to get a lot of information, but what information you need to improve your management or how efficient you should be in getting that information depends a lot on what decisions you're going to make. So thinking through what kind of information do I need? What do I not know that I wish I knew now or sooner or at a different scale? And use that to guide which data products you pursue. There are large-scale data sets currently available for visualization, for modeling, and for calculations. And a lot of this is stuff that you could engage with yourself through things like the Earth Explorer website. But throughout all of this, remote sensing on its own is not a silver bullet. The idea is to get better data into the hands of foresters and managers so that we can make better decisions for the landscape that we're taking care of. I think we have some time for questions. My email address is there. And the website link to our NCAPX program is also there now. So thank you very much, everyone, for your time today.
Great job, Nan. Thank you very much. So I've been, as you were going along, I was inserting web links and things like that into the chat window so people will be able to, they become hot links. People can click on them and just save those pages and then refer back to them as they wish. So if people have questions, this is a great time to start typing them in. For those of you that are interested in continuing education credits, you have already done what you need to do. You were solicited at the point of registration for the webinar for continuing ed information, and then I'll be processing that in the next few days. So I've got a couple of questions to kind of get things started. There was one or two that came in as well. So when you're during the presentation, you were talking about data sets, and I'm assuming that, like you said, you can download a data set, and you use the word raster, which that kind of scares me. It sounds like a great big column of numbers. So when you say data set, does that assume that there's going to be some mathematical processing required after you download that, or is that a map when you say data set?
Sure. It depends a lot on the particular data product. So things like if you want to download, for example, Landsat data from the Earth Explorer website, you can download either essentially raw data, which is going to be 8 bands worth of information, or you can download what they call, it's like a map viewer image of some sort. Those are the ones that I like to engage with if I'm not doing statistical modeling with, because that's what you can pull down and just load it into a GIS system and take a look. You do need a GIS system to engage with it. If you open it in like Paint, you have a picture, but you can't zoom as well and you don't know what you're looking at. But it doesn't mean downloading like a raw text file or CSV file of numbers that you have to process into more information.
Okay, that's good, because that expands the usability of it
yes.
significantly. So are there presumed like skill sets or capabilities from a mathematical quantitative perspective for somebody? I mean, so if they can, so you mentioned QGIS, which is a free GIS. So if you had QGIS and you went into Earth Explorer and pulled down Landsat, do you need to be able to use, what kind of skills do you need to be able to use QGIS? I mean, where I'm going with this is just to get a sense of, so the people that are sitting and listening is like, what's their potential for utility?
Sure. So for visualization, again, you just need to have some basic engagement with the GIS system. For quantitative information, if you're trying to say like, hey, can I get like density information for this area, you wouldn't go straight to Landsat, but you could look at some of the other like Forest Service products that are available, or some of what's available through Global Forest Watch has more like stocking and disturbance information that you could still summarize using sort of some like basic GIS skills, raster calculations and that kind of thing. When you get into concepts like change detection, if you're trying to quantify, not just say, I can see that a change occurred during this time frame, but quantify exactly what happened, then you're getting into having to use some more like statistical software and understanding a little bit more what the different bands mean and how to combine them. So there are tutorials available. And I think if somebody's interested in just understanding more how to work with the data, if you have some familiarity with programming at all, you could figure out what to do from finding some of the tutorials that are available on the internet. But in terms of getting as far as modeling for a structure the way that our team does, that does require a more advanced understanding of both the models and how to work with the data.
Sure. Okay. Okay. I've got some other questions, but people are typing things in, so I don't want to like dominate this option. So
and I see there's one comment in here from someone, Dan Hudnut writes, in early March I was told Basemap is no longer available as a standalone product. And that's specifically asking about SilviaTerra's Basemap data set. It's true that we're not currently selling that data set, simply because our team is right now very focused on getting our natural capital exchange up and running across the country. Basemap is available to owners with larger holdings through like a data cooperative program where we sort of trade Basemap for other field information. And again, it's also available. It's currently being used to underpin everything that we're doing for NCAPX, and we do have plans to make it more viewable and visible to people who are engaging through our platform in that way. But yeah, it is true that right now, if you send me an email and say, I'd like to buy some Basemap from you for this property, that's not something we're currently offering. I did want to clarify that.
Okay. So Carl asked, Nan, do you want me to read the questions, or do you want to, what's your preference?
I can just sort of start and then,
Okay.
yeah, I can go in.
So
from
there's,
the
if you see the timestamp, the first question started at 12:39, so it goes back to Carl prior to the one that you.
Great. Yeah. So Carl says this data can help with taking proactive actions to manage forests, to mitigate wildfires, and help improve forest quality. Any thoughts? It can also help prepare more refined cost estimates to help manage forest ecosystem services. Carl, I wholeheartedly agree. From my perspective as a scientist, yes, having landscape scale information that is also highly resolved is extremely useful for things like fire and sort of larger scale landscape restoration efforts, identifying both sort of the general condition and then targeting where management can take place. One of the things we're most excited about at SilviaTerra is taking our Basemap data and not just having a market where people can transact on forest carbon, but also facilitating a market valuation of other ecosystem services like wildlife habitat, like forest health, resilience, managing to reduce wildfire risk. And that's what our company is really focused on trying to explore and make possible over the next few years. Yorma asks, the species product you produce, is it lead or main species or all species in the 30-meter pixel? So what the product that SilviaTerra has, what we estimate at a 30-meter pixel is a list of trees. So similar to what you have if you're taking cruise data. So it's an estimated set of what might be at that 30-meter pixel in terms of species diameter and the count of trees. And so from that, we can work up both summaries of dominant species, but also overall species distribution in an area. Matt says, has there been any effort of ground truthing the prediction of dominant species at a 30-meter cell scale from Basemap? If yes, what's the average level of confidence assigned, and does it vary by region? The answer to that is like, yes, we have done comparisons of our Basemap data set to cruise data at individual points and stands in a range of forest types, mostly across the eastern US, but we're doing work in the West as well. We've also done comparisons using, in partnership with the Forest Service FIA regional offices, to use some of the other location information that they have associated with the FIA plots. I don't have a number in my pocket that I can share with you, but we are hoping to have sort of performance report information on our website within the next few months to share that kind of information. What I've seen out in the woods is that, like, in general, it's performing pretty similarly to what I see. So it's certainly not a precise measurement of what's at every individual pixel across the landscape, but generally we see that species, especially dominant species, are fairly well reflected within the Basemap data set. Amanda asks, 30-meter resolution seems low for identifying individual tree species. How does that work in mixed species hardwood forests? Yeah, that's a great question. So the approach that we have taken is, again, that we're not trying to identify individual stems, but rather identify sort of species importance or species mixtures, and using that, using plot level measurements where we get the same kind of summaries to generate that sort of species mixture information and then algorithmically process that into a list of individual trees that would look like that sort of plot level attribute that we're estimating. One of the things that we do is use multiple dates of the Landsat or Sentinel imagery to capture the changing phenology within a hardwood forest. So if you think about a species like beech, which retains its brown leaves in the fall and over the winter, you think about different hardwood species that leaf on at different times. And so we try to bring in a stack of information from multiple dates in the spring or fall, so that we can train models to capture those differences of like the amount of the way that it's changing over that time period, and use that to make better predictions about species composition. I think Ethan's question was fairly similar to that. We have a few minutes left. I can share a little bit more about the Natural Capital Exchange. I think that Peter also sent out in one of the emails about this presentation a link to a webinar that my coworker Alex did a few weeks ago. The Natural Capital Exchange is a 1-year carbon rental program. Landowners can enroll without any cost. There's actually no cost to landowners to participate all the way through. So you can upload a shapefile or go through the platform and identify a parcel of interest. And you request a report that comes back in about a week with an estimated number of carbons that you can choose to essentially submit to the marketplace. There's a lot of information available through our platform and through our website about exactly what that looks like. But as I said, in New York and Pennsylvania, enrollment is open right now for a 1-year commitment that begins July 1st. The commitment to a landowner is simply to defer harvest for 1 year. There's no other expectation there in terms of management activity, and there's no longer time commitment. It's just 1 year. So again, I would encourage everybody that's interested in that or might be interested, take a look at our website, and also see if I believe that my coworker Alex does like regularly scheduled webinars through a few different programs, so that there's another opportunity to hear from him how that works.
So I put the link to the program in general into the chat window a couple of times ago. And I tried to do it for the link to the webinar, but it was a really long link. So I'll refer people back to the registration email, or if you can't find that, then just send me an email and I can forward you the link to the webinar. Alex had given a webinar for New York, I think for New York, and maybe for one of the lake states as well recently. So those are available if people want to have more information on that. So, and those, I mean, I'd recommend you go back and see those. Those are going to talk specifically about those programs. I was grateful for having Dan talk more generally about like the science behind remote sensing and then processing that to create these kinds of resources. There are, let's see, do you know, so there's some more questions that are coming in. Jim's offered some links. So Artem is, I think, the next question.
Yeah. Artem, NCAPX is focused only, and hi Artem, we took silviculture together a long time ago. NCAPX is focused only on live above ground carbon. So standing dead trees are not really represented in the calculations and aren't being monitored or included in the estimates of carbon. Steve, have you considered using your technology to identify surviving chestnut trees in the wild? We have not targeted that in particular, primarily because our models rely on having ground measurements to be able to generate, like, this is what chestnuts look like. Just finding chestnut trees without having the ability to pair that with what a chestnut tree, like where they are, is sort of outside the scope of what we can do. Although I love this idea and I would like to be able to do it. And Jonathan, there's no minimum acreage enrollment for NCAPX. So there is a minimum cutoff of carbon, but we had landowners with as few as 15 acres enrolled in the first cycle of this year. And, regardless of the size of the property, I would encourage you to take a look and see if there's a path forward there.
That's very neat. So, Nan, thank you very much, and I want to thank everybody who participated. We topped out at about 115 at the noon hour. So, thank you all. Great presentation. I learned a lot, and I'm sure that everybody else did as well. So, we will call the noon hour to a close. Nan's going to be back again this evening at the 7 o'clock session. So, have a great afternoon. Yes, thank you.